So we're going to look to solve a problem. And the problem is, how do we find the slope of a tangent to a curve? So here's just some random curve, we'll call it y equals function x. And I want to find the equation of that blue line, the tangent. Now, of course, a tangent is a line. And we know the equation of a line. Well, if I know a point and a slope, I can find its equation. Well, I've got a point, but I haven't got a slope. Well, if I know 2 points on the line, I can find the slope. Only problem is I only know 1 point on the line. So how on earth can I find the slope? Well, I could estimate, because I know the equation of the red curve. So I could place Q on the red curve and find the slope of the green line there and use that as an approximation for the slope of the blue line. Now obviously where I've placed Q there, that'll be a lousy estimate. Okay? But it would be an estimate for the slope of K. So where, and here's the question, where should we place Q to get the best possible estimate? Where? We want Q as close to P as we possibly can. So let's just expand that. There we go. So ideally, I know the coordinates of P is x, function x. Q would be some point further along. Let's just say I've added h to the x coordinate. And its y value would be function x plus h. The slope of that line will be my estimate. Function x plus h minus function x over x plus h minus x, which is h. Okay. We want it as close as possible. Well, that's where the idea of limits come in. Now, of course, Q and P can't be the same point. But if I find the limit as it approaches 0, then I will find the slope of that line, because it'll tell me the value of this function as it approaches 0, which will be the slope of the tangent. So making use of limits, I can find the slope of the tangent. Now, that slope of the tangent, if you like, this formula is actually known as the derivative. The derivative of y with respect to x in this case. How does y change as x changes? Which, when you think about it, that's what slope is. How does y change as x changes? Different symbols we've used over the years. dy dx is probably the most common one. I think it originates from d coming from the Greek letter delta, delta meaning change. Sometimes we just use a prime. So y prime, some people just call it an apostrophe, or some people call it a dash. Okay, so y dash. Sometimes, just like we call the function x, the derivative we sometimes call f dash x or f prime x. Another way we can do it is just simply write the function itself and say, hey, I'm going to differentiate this particular function, whatever it happens to be, with respect to x. So they're all different ways we could write the derivative. But at the end of the day, the derivative measures the rate of something changing. Okay, I've introduced it looking at a number plane graph, but it could be anything. Anything that changes can be measured with a derivative, and that is the brilliance of calculus. Because when you think about it, measuring change is so important, because we often try to predict what's going to happen. The weather patterns. How's the weather going to change? And so calculus is involved in all these sorts of things. How does things change? So there's our formula. The derivative, f dash x, will be the limit as h approaches 0, function x plus h minus function x on h. It is known as differentiating from first principles. Now, all first principles means do it from scratch. You don't only have first principles in calculus, you can have first principles in anything. But if it asks you to solve it from first principles, it means derive it from scratch. And so in calculus, if we say do it with first principles, we go right back to this formula to work it out. All right, let's put some meaning behind it. So if I've got y equals 6x plus 1, and I differentiate it. Now, remembering of what it actually measures, you should be able to tell me the answer already. Because what did we say our derivative is going to measure? What's the slope of that line? right? Because a tangent to a straight line is the line itself. I should end up with the answer of 6. So function x is 6x plus 1. Function x plus h, if I sub in, we'll get 6x, say that again, 6x plus 6h plus 1. Sub that into my derivative formula. You'll notice I'm now using the dy dx notation. I tend to do that. If they've quoted it as y equals, I tend to use dy dx. I sort of match the notation. If they say function x equals, then I'll write f dash x. Sub in. Now there'll be a bit of cancelling happening there. I've just got 6h on h. The h's cancel. Well, there's nowhere to sub 0 in. It's going to be 6 no matter what h is. And there it is. My derivative is 6. Okay. So if I now come back to what the whole point of this was, let's find the equation of a tangent at some point. Well, I've got a parabola, which is a curve. I'm going to have to differentiate function x plus h. By the way, do you remember back when we were doing algebraic fractions and things like that? They had those questions they got you to do, function x plus h minus function. That's why, when we get to this. Let's sub it in. Function x plus h minus function x all over h. By the way, when you're setting out limits, remember you keep writing limit until you do the substitution. So limit as h approaches 0 of this. And hopefully if we've done it right, we should always get a situation where the h will cancel. And we've got that here. So I've got 2x plus h minus 5. H approaches 0. 2x minus 5. Now, 2x minus 5 is not the slope of the tangent. 2x minus 5 is the formula that allows you to find the slope of the tangent. Okay. So we want when x equals 1. When x equals 1, that derivative is going to be negative 3. I now have the slope of the tangent. So the slope of the tangent is negative 3. Point slope formula. I should be able to work out the equation of my tangent. There it is. Y equals negative 3x plus 1. That's all for today. Now, I've just made a note here. There are different formulas for first principles. Don't worry about the other ones. I mean, this is the simplest one I think of, really. So in those questions there, just worry about the ones where we just use h approaches 0 rather than x approaches c, I think it is, or something like that.